Okay, so let's do this. So let's do the answers. Okay, so first off, find the root. Assume that all variables represent non-negative real numbers. So it means I don't have to worry about uh, any absolute values in this particular case. So this is equal to negative fourth root of 256 times the fourth root of x to the 12 times the fourth root of y to the 8. Well, this is going to equal, the fourth root of 256 is 4. Since 4 times 4 is 16, times 4 is 64, times 4 is 256. Next, 12 divided by 4 is 3, and so the fourth root of x to the 12 is x cubed. And I don't have to worry about the absolute values in this case because it says that x here is non-negative. The fourth root of y to the 8, well, 8 divided by 4 is 2, and so I get y squared. And that is your answer. Let me do problem number 2. The fourth root of 625, x to the 8, y to the 16. So this is equal to the fourth root of 625 times the fourth root of x to the 8 times the fourth root of times the fourth root of y to the 16. And so this is equal to, well, the fourth root of 625 is 5. Since 5 times 5 is 25, times 5 is 125, times 5 is 625. 8 divided by, so the fourth root of x to the 8 is 8 divided by 4 is 2, so it's x squared. The fourth root of y to the 16, 16 divided by 4 is 4, so y to the 4. And that is your answer. Okay. Any questions on that? Okay. Simplify. Assume that all variables represent real numbers. So in this case, we're going to have to be careful because they do allow both positive and negative variables. Okay, so the fifth root of y to the fifth, well, 5 divided by 5 is 1. It is an odd power, so I don't have to worry about any absolute value. The square root of 9x squared is the square root of 9 times the square root of x squared. The square root of 9 is 3. The square root of x squared is going to be the absolute value of x, since we have an even root, the square root. And so 3 absolute x. And 2 divided by 2 is 1, so that's the first power. Similarly, the sixth root of x to the sixth, since 6 is an even number, and 6 divided by 6 is 1, it's just going to be x. And since I'm taking the even root, then this I have to have an absolute value. The square root of y plus 7 quantity squared, again, since I'm taking a even root, then I have to have the absolute value. So this is the absolute value of x plus 7. Since the square gets rid of the square root, but you may have, but it also gets rid of the sign, so you need absolute value. Let me do problem 7. The square root of x squared plus 6x plus 9. Well, what's in the radicand is a perfect square trinomial. So this is the same as the square root of x plus 3 quantity squared, since x plus 3 quantity squared is just equal to x squared plus 6x plus 9. And so this is equal to the square root of x squared of some quantity squared. Well, the square root gets rid of the square, but it also gets rid of the sign. And so this is equal to the absolute value of x plus 3. And that's your answer. Let me do problem number 8. The cube root says, use radical notation to write the expression, simplify if possible. So this is equal to the cube root of 216 times the cube root of x to the 12 question. So for even, we need absolute value, but for odd, we leave it alone. Correct. And so if you noticed here, when we had the fifth root of x to the fifth, since 5 is an odd number, we just said it was x. But we had the sixth root of x to the sixth. Again, that was an x, but I needed absolute value because 6 was even. So for odds, you don't need absolute values. For evens, you need absolute values. Any questions about that? So the answer is yes. Your statement is correct. Okay. The cube root of 216 is 6. Since 6 times 6 is 36 times 6 is 216. The cube root of x to the 12, 12 divided by 3 is 4. And so it's 6x to the 4. Okay. And so this is equal to negative 27 x to the 15 all to the power 1/3. Well, 1/3 is a cube root, so this is a cube root of negative 27 times the cube root of x to the 15. The cube root of negative 27 is just negative 3. Since negative 3 times negative 3 is positive 9, times negative 3 is negative 27. 15, so the cube root of x to 15 is, well, 15 divided by 3 is 5, so x to the 5th. And so this is equal to a negative 3x to the 5. Use the property of exponents to simplify the expression. Write with positive exponents. Okay, and so let's first raise everything inside the parentheses to the power 2. So this is equal to 9 x to the 5/3 squared. Well, 2 times 5 is 10 thirds over x to the 1/6. Let me write. So I have here x's in the numerator and denominator. I'm just going to, since I have the same base, I subtract exponents. So let's subtract 10 thirds minus 1/6. Well, in order to do that, I need a common denominator. So let me multiply and divide by 2 here. And so this is the same as 9x to the 26 over x to the 1/6. 26, and so I have the same base, x. I have that 26 is bigger than 1/6, and so let's keep x in the numerator and subtract exponents. 20 over 6 minus 1 over 6 is 19 over 6. And that is your answer. Next. X to the 4/3 times x to the 6/5 divided by x to the negative 1/2. Well, since I have a negative exponent, I will bring this up from the denominator into the numerator. And when I do that, I'm going to change the sign of the exponent. So this is x to the 4/3 times x to the 6/5 times x to the 1/2. Remember that you're going to have to change the sign of the exponent when you bring it up. Now, I have the same base, I'm multiplying, so you just add exponents. Well, I need a common denominator because there's all fractions. So let me get the common denominator. I have a 3, a 5, and a 2, and so the least common denominator is 30. So we have a whole bunch of x's to some power over 30. So let me multiply and divide by 10, by 6, by 15. And so I get 40 over 30, 36 over 30, and 15 over 30. And so 40 plus, and so I have the same base x. I'll add exponents. Maybe I'll write it over here then. And so since I have the same denominator, common denominator, all these are going to be over the common denominator. Let's add 40 plus 15 is 55 plus 36 is 91. And so I get x to the 91 over 30. Let me do problem number 12. This is x to the 1/9, s to the 1/9 squared. So I'm going to square both of these. So x to the 1/9 squared, not x. Sorry. R to the 1/9 times s to the 1/9 squared. Well, I have a base to an exponent. You just multiply exponents and keep the same base. 1/9 times 2 is 2/9. Again, I have a base to a power, raised to a power, so I multiply exponents. 1/9 times 2 is 2/9. And that is your answer. Okay. Use rational. Oops. Sorry about. Okay, sorry about that. Use rational exponents to write as a single radical expression. Okay, so this is equal to y to the 1/4 over y to the 1/5. Okay, and so let me subtract. I have the same base, y, and 1/4 is bigger than 1/5. So let's subtract, since I'm dividing, I subtract exponents. In order to subtract 1/4 minus 1/5, I need a common denominator. So the common denominator is 20. So let me multiply and divide by 5. Multiply and divide by 4. And so I get y to the 5 over 20 divided by y to the 4 over 20. And so that's going to equal y. I have the same base, so I'll keep the base y. 5 over 20 is bigger than 4 over 20, so y will be in the numerator. 5 over 20 minus 4 over 20 is 1 over 20. And finally, they say to write as a radical expression. So let's write this as a radical expression. So this is the 20th root of y. And that is your answer. Any questions about that? Okay, next. I have here x to the ninth root of x. So this is x to the 1/9. The cube root of x squared, so that's x to the 2 to the power 1/3. So this is x to the 1/9 times x to the 2/3. In order to simplify this, I'm going to have to get a common denominator. The common denominator in this case is 9. So let me multiply and divide by 3. And so I get x to the 1/9 times x to the 6/9. So I'll add exponents. 1/9 plus 6/9 is 7/9. And so let's write this in radical notation. So this is the 9th root of x to the 7. And that is your answer. Any questions about that? Let me do problem number 15. The square root of 13 x cubed times the square root of 13 x to the 5th is the same as the square root of 13 times 13, 169, x cubed times x to the 5th, x to the 8. And so I can take the square root of each of these, square root of 169, square root of x to the 8. The square root of 169 is 13. The square root of x to the 8, well, 8 divided by 2 is 4. So x to the 4. And that is your answer. Let me do problem number 16. Simplify the radical expression. Assume that all variables represent positive real numbers. Okay. So this is the same as the 7th root of, I want to write x to the 47 as the product of two terms, one of which is the largest perfect 7th power. Well, x to the 42 times x to the 5 is x to the 47. And 42 is divisible by 7. And so this is equal to the 7th root of x to the 42 times the 7th root of x to the 5th. The 7th root of x to the 42 is x to the 6. 42 divided by 7 is 6. And, well, you can't really do anything else. So times the 7th root of x to the 5th. And that is your answer. Let me do problem number 17. So this is equal to the cube root of, let me write negative 27 a to the 11 b to the 7 as the product of two terms, one of which is the largest perfect square, a perfect cube factor of this expression. So I have here a negative 27 a to the 9 b to the 6. The cube root, oh, I forgot the times Um, a to the ninth times a squared is a to the 11. B to the sixth times b to the first is b to the 7. And so this is equal to the cube root of negative 27 is negative 3. The cube root of a to the 9, well, 9 divided by 3 is 3. The sixth root of b to the cube root of b to the sixth, 6 divided by 3 is 2, times, well, the cube root of a squared b. And that is your answer. Let me do problem number 18. So this is equal to the square root of 189 x to the fifth y to the sixth over 3y to the 4. Since I have here, oops, to the 6th. Since I have the square root of a quantity divided by the square root of this quantity by the properties of exponents, this is the same as the square root of those two quantities divided by each other. And so 189 divided by 3 is 63, x to the fifth. Y to the sixth divided by y to the fourth, 6 minus 4 is 2. So y squared. Okay. Let me write 63 as 9 times 7. Let me write x to the fifth as x to the fourth times x, and y squared is just y squared. And so this is equal to, the square root of 9 is 3. The square root of x to the 4 is x squared. The square root of y squared is y. Since each of these represent positive, each of the variables represent positive real numbers. Times, well, I can't really do anything with the last part. So radical 7x. And that is your answer. Any questions about that? Let me do problem number 19. So again, I can use the properties of exponents to write this as all under one big square root. So 250 x to the 11 divided by 10x. 250 divided by 10 is 25. X to the 11 divided by x is x to the 10. Boy, that looks like a 16. So x to the 10. The square root of 25 is 5. The square root of x to the 10, well, 10 divided by 2 is 5. Let me do problem number 20. Add and subtract, assume all variables represent positive real numbers. And so this is equal to, I think I need more space. Okay, so let's add a page. Okay, so I have here problem 20. Okay. And so problem 20 says the square root of 3x squared minus 3 square root 108 x squared minus 4 radical 108 x squared. So let's simplify this. So the square root of x squared is just x. Oh, and here again they say add or subtract, assume all variables represent positive real numbers. So I don't have to worry about absolute value. And so this is the square root of x squared is just x, rad 3, minus, let's write 108 as 36 times 3, and x squared is just x squared. Again, let's write 108 as 36 times 3, and x squared is just x squared. So this is equal to x rad 3 minus 3 times the square root of 36 is 6. The square root of x squared is x rad 3 minus 4. The square root of 36 is 6. The square root of x squared is x rad 3. And so I have 1x rad 3. 6 times 3 is minus 18x rad 3. 4 times 6, 24 x rad 3. Okay, and so they're all now like terms. They're all quantities involving x rad 3's. So I have 1 minus 18 of them minus 24 of them. So negative 18 minus 24 is 42. And so I have 1 x rad 3 minus 42 x rad 3 is a negative 41 x rad 3. Let me do problem number 21. Oh, I have enough room now. So this is equal to 8. Let me write the fourth root of x to the 7 as the fourth root of x to the 4 times x cubed. Let's write, oh, and then that's just the same thing. So 2x fourth root of x cubed. And so I have here 8. The square root, the fourth root of x to the fourth is, again, x, since x here represents a positive real number, times, well, the fourth root of x cubed minus 2 of these, x rad 3's. And so 8 of them minus 2 of them are 6x rad 3. Okay. Let me do, problem number 22. Yeah, I may not have enough room here. So let me do problem 22 on the next page. Okay, so problem number 22. 9 cube root x cubed wider than 13 minus 2xy cube root 8 y to the 10. Okay, so this is equal to, let me write, well, the cube root is okay. So let me write the cube root of x cubed y to the 12th times y. Notice that each of these are perfect cubes. The x to the 3 and the y to the 12 minus 2xy cube root of, let's write this as 8 y to the 9 times y. And so this is equal to 9. The cube root of x cubed is just x. The cube root of y to the 12 is, well, 12 divided by 3 is 4 times, well, the cube root of y. And so I have here the cube root of 8 is 2. The cube root of y to the 9, 9 divided by 3 is just 3. And so I have 9 xy to the 4th rad y minus 2 times 2 is 4 x y times y to the 3rd is y to the 4th rad 2 rad y. And so these are now like terms. I have 9 of these minus 4 of them. And so 9 minus 4 is 5x rad y. And that's your answer. Let me do problem number 23. Multiply and then simplify if possible. Assume all variables represent positive real numbers. Okay, so again, we don't have to worry about any signs. And so let's multiply the rad 7 inside the parentheses. And so I get rad 35 plus rad 21. And that's your answer. Again, let's multiply the 4 rad 3 inside the parentheses. And so 4 rad 3 times rad 11, well, I have like radicals, so I can just multiply each of the radicands. That's 4 rad 2 times, 3 times 11 is 33, plus 4 times, well, rad 3 times rad 3 is 3. And so you get 4 rad 33 plus 12 as your final answer. Let me do problem number 25. And so this is one of our special product formulas. Let's multiply. And so rad 10 times rad 10 is 10. Rad 7 times rad 7 is 7. 10 minus 3, 10 minus 7 is 3. Let me multiply this out. The cross terms actually will cancel, but, and so I have here, let's multiply these. Oops. I showed it up on the wrong one. And so let's multiply these. And so rad 5 times rad 10 is rad, well, 10 times 5, 50. Rad 10 times 2 is rad 20. Negative rad 50 times rad 5. Okay, and so I get 50 minus 20 Rad 50 times 5, rad 5 is a negative rad 2 to 50, minus rad 50 times 2 is rad 100. Okay, and so let me write this as 25 times 2 minus rad 20 minus 25 times 10 and the square root of 100 is 10. And so, question? No, I guess not. Oh, and so I get square root of 25 is 5. Oh, maybe I'll just write it here. Oh, there's a question. How about 20? Oh, yes. Thank you. 4 times 5. Oh, why are they all negative? Because I'm stupid. Thank you. I'm sorry about that. Red 10, positive times positive is positive, so that's a positive there. Okay, and so this is equal to, the square root of 25 is 5, so it's 5 rad 2. The square root of 4 is 2, so it's 2 rad 5. The square root of 25 is 5, so minus 5 rad 10, and then minus 10. And that is your answer. There are no further like terms, so that's as simple as you can get it. So it's 5 rad 2 plus 2 rad 5 minus 5 rad 10 minus 10. Okay, let me do problem number 27. And so um, I'll use the special product formula. A plus B quantity squared is A squared plus 2AB plus B squared. And so I have that rad x minus 2 plus 9 quantity squared is just equal to, well, the rad squared, but the square gets rid of the square root, so it's just x minus 2 plus, well, by the special product formula, it's just equal to the radical plus times 9 times 2. Well, 9 times 2 is 18, rad x minus 2, plus 9 squared is 81. And so you get x plus 81 minus 2. 81 minus 2 is 79. Well, let me just write this. Plus 18 rad x minus 2. 81 minus 2 is 79. So plus 79. And that is your answer. Let me do problem number 28. Rationalize the denominator and simplify. So this is the same as the cube root of 10 over the cube root of 9. Well, 9 is 3 squared. So I have already 2 3's in the denominator. I want another 3 in the denominator so that this will become a perfect cube in the denominator. And so 3 times 10 is 30. So this is rad 30 over rad. 9 times 3 is 27. The cube root of 27 is 3. So I get rad 30 over 3. And again, I'm assuming, well, in the future, all variables are positive. Okay, so let me do problem number 29. So this is equal to 7 over rad 27. I can write as 9 times 3. The square root of 9 is 3. And so let's rationalize the denominator. Let me multiply and divide by rad 3x. And so this is equal to 7 rad 3x over, well, rad 3x times rad 3x is just 3x. And so this is 3 times 3x. And so I finally get 7 rad 3x over 3 times 3x is 9x. And that is your answer. Let me do problem number 30. So this is equal to, well, I want to rationalize the denominator. I already have 3 a's in the denominator, so I need one additional a in the denominator. So let's multiply and divide by rad a. And so this is equal to 3 rad a divided by, well, a cubed times a is a to the fourth. The fourth root of a to the fourth is just a. Again, I'm assuming that the radicand is positive. Okay. And so let me do problem number 31. 5 over rad 10 minus 6. So let me multiply and divide by the conjugate of the denominator, rad 10 plus 6. So rad 10 plus 6. So this is equal to, let me multiply the 5 inside the parentheses. And so I get 5 rad 10 plus, well, 5 times 6 is 30 over rad 10 minus 6 times rad 10 plus 6. This is the product of the sum and difference of two terms. And so the product will be the difference of squares. So rad 10 times rad 10 is 10. Minus times negative times positive negative. 6 times 6 is 36. And so I get 5 rad 10 plus 30 all over a negative 26. Okay. And so I've rationalized the denominator. Any questions about that? Okay. Let me do problem number 32. And so again, I want to rationalize the denominator. So let me multiply and divide by the conjugate of the denominator. The conjugate of the denominator is rad b minus rad w. So rad b minus rad w. So this is equal to, let me multiply the rad b inside the parentheses. Rad b times rad b is b. Oops. Rad B times rad B is B. Rad B times rad W is rad BW. Again, this is a product of the sum and difference of two terms. So rad B squared is B, rad W squared is W. Okay. And so I've rationalized the denominator. Any questions about that? Okay. Question. Oh, why can't you cancel the B's? Okay. Well, it's because you can only cancel things that they're factored. And so suppose I had something like, I don't know, 6 minus 2 over 6 plus 3. Okay. So 6 minus 2 is 4. 6 plus 3 is 9. Now, if you had somehow tried to cancel the 6's, you would get something like a negative 1 over 4, which is certainly not the same. So the problem is that you have here, what was it? It was a B minus rad BW over B minus W. So just like the 6 here, even though the 6's are out, are the same, since you're not able to factor it out, you can't cancel this. The only time you could cancel is if you had the situation where it was like, I don't know, B and then 1 minus rad BW over B 1 minus W, let's say. There you could cancel the B's, but only in the case that there's some sort of common factor. And so somehow you've sort of factored out the B or whatever from both the numerator and denominator. Okay, so did that answer your question? Yeah. So you cannot cancel the B's. That is correct. Okay. Okay, good. Let me do problem number 33. Um, I don't think I'm going to try to squeeze that. So let me do problem 33. So let me put it up here. Okay, so I want to rationalize the denominator. So I have here 6 rad 5 plus rad 10 over 6 rad 5 minus rad 10. I want to rationalize the denominator, so let me multiply and divide by the conjugate of the denominator. 6 rad 5 plus rad 10. And let me divide by that same quantity. Okay, oops. 6 rad 5 plus rad 10. Okay, so let's multiply this out. 6 rad 5 times 6 rad 5 is 36 rad 5. Oops. 36 times Rad 5 times rad 5 is 5. There are going to be two of these. 6 rad 5 times 10 is 6 rad 50. Plus another 6 rad 50 gives me 12 rad 50. Plus the square root of 10 times the square root of 10 is 10. Over, well, again, this is the product of the sum and difference of two terms, so it's the difference of their squares. 6 rad 5 times 6 rad 5 is, well, 36 times 6 times 6 is 36. Rad 5 times rad 5 is 5. Positive times negative is negative. Rad 10 times rad 10, the square root of 100 is 10. And so this is equal to 36 times 5 is 180 plus 12. Let me write 50 as 25 times 2 plus 10 over, again, 180 minus 10. And so, 180 plus 10 is 190 plus 12 times the square root of 25 is 5. We're at 2 over. 180 minus 10 is 170. And so this is equal to 190 plus 12 times 5, 60. We're at 2 over 170. Well, I can factor out a 10 from the numerator. So it's 10, 19 plus 6 rad 2 over 170. And so I can cancel, I can divide by 10. So this is equal to, I have to squeeze it, 19 plus 6 rad 2 over 17. And that is your answer. Let me do 34. Actually, I'm going to need space for all those, I guess. Well, maybe not for the first one. So let me do let me do the first problem. So rad 4x equals negative 2. Okay, so let's try to solve this radical equation. So problem number 34, the square root of 4x is equal to negative 2. Okay, so let me square both sides of my equation. The square gets rid of the square root. Negative 2 squared is 4. Divide both sides of the equation by 4. And so x is equal to 1. Now you're going to have to check when x equals 1. Is the square root of 4x equal to negative 2? Well, the square root of 4 is 2, but it's not negative 2. And so, no, they're not equal. And so this is an extraneous solution. Since this was the only possible solution, then the answer is no solution. Let me do problem number 35. And so problem 35. which is radical 2x minus 9 minus 2 equals 0. Okay, so radical 2x plus 9 minus 2 equals 0. Okay, so first let's isolate the radical on one side of my equation. So if I add 2 to both sides of my equation, you get radical 2x plus 9 equals 2. Hello. Let me square both sides of my equation. The square gets rid of the square root. 2 squared is 4. Subtract 9 from both sides of my equation. So 2x equals negative 5. Divide both sides of my equation by 2. So x is equal to negative 5 over 2. Okay, now let's check. If x equals negative 5 halves. And so, maybe I'll put a little line here. And so is the square root of 2 times negative 5 halves plus 9 minus 2 equal to 0. Okay, well, let's check. The 2's cancel, so you get the square root of a negative 5 plus 9. And so you get is the square root of 4 minus 2 equal to 0. And well, the square root of 4 is 2. Minus 2 is indeed equal to 0. And so x equaling negative 5 over 2 is my solution. Let me do problem number 36. Radical Oops. Let's try that again. Radical 4x plus 3 is equal to 3. Okay, so let me square both sides of my equation to get rid of the square root. So I've already isolated a radical on one side of my equation. So to get rid of the radical, just square both sides of the equation. So the square gets rid of the square root. So you just get 4x plus 3 is equal to 3 squared is 9. Subtract 3 from both sides of your equation. So 4x is equal to 6 divided by 4. So x is equal to 6 over 4. I can divide both 6 and 4 by 2, so I get 3 halves. So now let's check. And so is the square root of 4 times 3 halves plus 3 equal to 3. 4 divided by 2 is 2 times 3 plus 3. Is that equal to 3? 2 times 3 is 6. plus 3 is 9. Is the square root of 9 equal to 3? Yes. And so x equaling 3 halves is a solution. Let me do problem number 37. So let's insert an additional page. So that was what, 36. So let's do 37. Radical 21 minus x is equal to x minus 1. So let me square, since the radical has already been isolated on one side of my equation, let me square both sides of my equation to get rid of the square root. And so the square gets rid of the square root, so I just have 21 minus x. X minus 1 quantity squared by the special product formula is x squared. X times negative 1 times 2 is the negative 2x. Plus negative 1 squared is 1. Okay. Now let me add x, subtract 21 from both sides of my equation. And so I get x squared minus 2x plus 1x is minus 1x. 1 minus 20 is 1 is minus 20. And so let me factor. So I have here x. This is a monoquadratic. Drop down the minus times minus is positive. I want two whole numbers whose product is 20 and whose difference is 1. So 5 and 4. So I get x minus 5 is 0 or x plus 4 is 0. So either x is 5 or I have to figure out another way. X is equal to negative 4. Okay, let me see who that was. Isn't it a positive x? No, because it's negative 2x plus 1x. Gives me a negative 1x. Yeah. Okay. And so now let's check. I'm going to have to check at two different places. Let's check x equal 5. And so this is 37. Is the square root of 21 minus 5 equal to x minus 1. So 5 minus 1. 21 minus 5 is 16. 5 minus 1 is 4. Is the square root of 16 equal to 4? Sure. Let me check number if x equals negative 4. And so let's check. Is the square root of 21 minus a negative 4, so that's plus 4, is that equal to x negative 4 minus 1? And so 21 plus 4 is 25. Is the square root of 25 equal to negative 5? And the answer is no. And so I have to get rid of this contender. So only x equaling 5 is a solution for this particular question of this particular radical equation. Okay. Let me do problem number 38. So problem 38, radical 9x minus 17 equals 3 minus x. So I've isolated the radical on one side of my equation. Let me square both sides of my equation. And so the square will get rid of the square root, and I'll have to use a special product formula for the second part. And so the square gets rid of the square root, so I get just 9x minus 17 is equal to, well, let's multiply this out. So by the special product formula, this is just 3 squared, 9. 3 times negative x times 2 is a negative 6x. Plus, well, x squared is x squared. Okay. So let me subtract 9x, add 17 to both sides of my equation. And so I get x, let me write this in descending order. X squared minus 6x minus 9x is minus 15x. 9 plus 17 is 26. And so let's try to factor this as a monic trinomial. And so I have minus times positive is negative. So I have two negatives. I want to find two numbers whose product is 26 and whose sum is 15. So 13 and 2. Set each factor to 0 and solve. So x is equal to 2. And x is equal to 13. Now let's check. Problem 38. Let's check what happens when x is 13. Okay, so let me insert another page, I guess, so I can do this. Okay, so let's check. Let's plug in 13 into the original. And so, is the square root of 9 times 13 minus 17, is that equal to 3 minus 13? Okay, so let's do that. 9 times 13, 117 minus 17, is that equal to 3 minus 13 is a negative 10. 117 minus 17 is 100. And so the square root of 100 is indeed 10. Okay. Next, so this is a solution. Next, I've got to check x equaling 2. Oh, wait. Of course it's wrong. Thank you. So x is equal to, sorry, that was a typo there, -10. So is this equal to -10? And the answer is no. So that was an extraneous solution. Okay. Now let's check. So for problem 38, let's check 2. And so is the square root of 9 times 2 minus 17 equal to 3 minus 2? Is the square root of 18 minus 17 equal to 1? Well, 18 minus 17 is 1, and indeed the square root of 1 is equal to 1. And so x equaling 2 is a solution. So in this case, you just have a unique solution, the unique solution being x is equal to 2. Okay, let me do problem number 39. And so I have here the square root of 24 x minus 48. Is that equal to x plus 4? Okay, so again, I've isolated the radical on one side of my equation. So to get rid of the radical, all I have to do is square both sides of my equation. So let me do that. So if I square both sides, the square gets rid of the square root, so I get 24x minus 48 is equal to x plus 4 quantity squared is x squared plus 8x plus 16 by the special product formula, the perfect square trinomial formula. Let me try to set one side of this equation equal to 0. And so let me subtract 24x from both sides of my equation. Add 48 to both sides of my equation. And so, let me make that look nicer. And so I have here x squared. 8 minus 24 is a negative 16x. 48 plus 16 is 64 equals 0. So let me factor that. That's just x minus 8 times x minus 8. It's a perfect square trinomial. Set each factor to 0, so x minus 8 to 0. And so I get x is equal to 8. So let's check. X equal 8. Let me get another page. Okay, so let me check. Problem was at 39. The square root of 24x minus 48, is that equal to x plus 4? Okay. And so let me multiply 24 times 8. So I get the square root of 192 minus 48. Is that equal to 12? 192 minus 48 is 144. Is the square root of 144 12? Yes. So 8 works. Okay. Let me do problem number 40. X minus rad 24x minus 24 equals negative 5. Okay. So first thing to do is isolate x on one side of your equation. So let me subtract x from both sides of my equation. So I get negative radical 24x minus 24 is equal to a negative x minus 5. Let me square both sides of my equation to get rid of the square root. Well, the square of a negative 1 is just 1. The square gets rid of the square root, so I just have, 24 x minus 24. Let's square the right-hand side of my equation. Well, this is a perfect square trinomial. Negative x quantity squared is x squared. Negative x times negative 5 times 2 is a positive 10x. Plus a negative 5 quantity squared is 25. Let me subtract 24x from both sides of my equation. Add 24 to both sides of my equation. And so I get x squared minus 24x plus 10x is minus 14x. 25 plus 24 is 49. And so this factors into x minus 7 times x minus 7. Okay, and so let me set each factor equal to 0 and solve for x. So x is equal to 7. Now let's check x equals 7. And so is x minus the square root of 24 times x minus 24, is that equal to negative 5? Okay, so let's check. Is 7 minus the square root of 24 times 7, 168, minus 24, is that equal to negative 5? And so 168 minus 24 is 144. The square root of 144 is 12. Is 7 minus 12 equal to negative 5? Yes. Therefore, x equaling 7 is a solution. Okay. Let me do problem number 41. Nope. 41 is above. Okay. 41. So those were longer problems, so obviously I couldn't quite do them on the review sheet. Let me do problem number 41. Write in terms of I. Well, the square root of 400 is 20. The square root of negative 400 is 20i. And that is your answer. 42. The square root of a negative 144. Well, the square root of 144 is 12. Therefore, the square root of a negative 144 is 12i. And that is your answer. Let me do problem number 43. And so it says here, multiply or divide. And so let's multiply this. And so I have rad 3 times the square root of negative 27 is the same as the square root of negative 9 times 3. Well, the square root of negative 9 is just 3i. The square root of 3 times the square root of 3 is 3. 3i times 3 is 9i. Let me do problem number 44. And so I have the square root of 25 over the square root of negative 2. And so this is the same as square root of 25, which is 5, over the square root of negative 2, which is I rad 2. It actually doesn't say to rationalize the numerator or denominator, but I guess I'll probably do that because I imagine that's the way she wrote her answer. So let me rationalize the denominator. So let me multiply and divide by negative I rad 2. And so if I do that, I get 5 times negative I rad 2 is a negative 5 I rad 2. Positive times negative is negative. I times I is I squared. Uh-oh. 2 times 2 is rad 2 times rad 2 is 2. And then hopefully you're not going to lose the vision for a second, but if you do, I'll have to switch this around. Okay. So let me ask everyone, are you still able to see the screen, or did it blank out because I had to put in the... Yes, you can still see it? Okay, good. Okay. So this is equal to negative 5 I rad 2. I squared is a negative 1, so that becomes a negative 1 times 2. Negative times negative is positive, and so you just get a negative 5I rad 2 over 2. And that is your answer. Let me do problem number 45, which is probably several pages down now with all those radical equations that I did. Okay, there it is. Problem 45. So I have a little bit of room at there. Perform the indicated operations, write the results in standard form, A plus BI. Okay, so by the special product formula, this is a perfect square trinomial, a perfect square trinomial formula. And so this is equal to 8 squared, 64, plus 8 times 9i, 72i, times 2, 144i, plus 9 squared is 81, I squared. Recall that I squared is negative 1. And so this positive 81i squared becomes a negative 81. And so if I subtract, I get 64 minus 81, negative 17, plus 144i. And that is your answer. Let me do problem number 46. I'll put it right here. I have a 9 over 8i. So let's rationalize the denominator. So let me multiply and divide by a negative I. So I get here a negative 9i over a negative 8i squared. But again, recall that I squared is a negative 1. So we get a negative 9i over a negative 8 times negative 1. And so this is equal to a negative 9i over 8. Okay. Let me do problem number 47. Maybe I'll put it up here. 47. 9 over 4 plus 3i. So let's multiply and divide by the conjugate of the denominator. 4 minus 3i. And so, if I multiply the 9 inside the parentheses, I get 36 minus 27i divided by, this again is the product of the sum and difference of two terms. And so this is equal to the difference of their squares. 4 times 4 is 16. Positive times negative is negative. 3i times 3i is a negative 9i squared. But again, I squared is negative 1. So this is 36 minus 27i over 16 plus 9. And so this is just a 36 minus 27i over 25. And so writing the standard form, you have 36 over 25 minus 27 over 25i. And that is your answer. Let me do problem number 48. I don't know. Let's try to do this, I guess. And so this is equal to, maybe I'll give some more room up here. And so this will equal 4 plus 6i over 9 minus 3i. So let's multiply and divide by the conjugate of the denominator. 9 plus 3i. 9 plus 3i. Let me see what if I wrote something wrong. Oops. There you guys are. Oh, I'm sorry. I will slow down writing. as best I can. Sure, let me do that. Ah, so why don't you write that down? And of course, um, at the conclusion of this, you can always look at the videotape, at the taping of this, and you can, go at any speed you wish. Let me see if they're done. Okay. When you're done, just sort of tell me so I can scroll back to the previous. Sorry, I guess you guys fell back much further than I thought. Sorry about that. Can I scroll down yet? Let me scroll. Okay. Thank you. Okay, good. Okay, so now let me multiply this out. Oops. 4 times 9, 36. 4 times 3i, 12i. 9, 6i times 9, 45i. 6i times 3i, 18i squared. This is a product of the sum and difference of two terms, so it's the difference of their squares. 9 times 9 is 81. 3i times 3i is a negative 9i squared, which is just equal to negative 1. And so I get 36 plus 12i plus 45i is 57i. The I squared becomes a negative 1, so the positive 18i squared becomes a negative 18. The negative 9i squared, since I squared is negative 1, becomes a positive 9. 36 minus 18, 18 plus 57i over 27, over 91. And that is your answer. Oh, but let's write it in. So this is equal to 47. So let me write it as 18 over 91 plus 57 over 91 I. Okay. So that finishes off number. Why is 81 plus what the heck? What the heck? That's probably the question. Yes, y is 81 plus 991. I have no idea. Okay, but luckily that means you can factor things out then. Okay. Um, so let me write this as I can factor out a 3, that's 30, 9. I can factor out a 9. So just a 3 from there. Okay, so that's 40, 57. Question, yeah, let me just check. Okay, yeah, I got to check something here. Are you writing? No, not the second actually. I'm trying to check something here. Sorry. Okay, so that's 36, 12. What the heck? Oh man. Okay. Uh, there's an error right here. Okay, so what I'm doing right now is actually erasing. Because there was an error. Uh, I wrote 45 and it was supposed to be 54. Yes, that was the error. It's 54. Okay, so let's multiply this out correctly. 4 times 9 is 36, plus 4 times 3 is 12i. 6 times 9, 54i. 6 times 3 is 18i squared. Over 9 times 9 is 81. 3i times 3i is 9i squared. And so you get 36 plus 66i minus 18, since I squared is negative 1, over 81 plus 9. So I get an 18 plus 66i all over 90. Oh, so you can divide by, so you can do 3. So this is equal to, let me write it this way, 18 over 90 plus 66 over 90i. But I can divide both 18 and 90 by 18. So this is equal to 1 over 5. Plus, I can divide both 66 and 90 by 6. So I get 11 over 15 by 6. Wait. Yeah, divide by 6. 11 over 15 I. And that's your answer. Finally. Okay. Let me do problem number 48. Any questions about that? Since that was kind of confusing. Since I made an error. I wrote 45 instead of 54. Okay, let me do problem 48. Okay. Oops. So let me do 48. And so let's do that. So problem 48. Oh, probably didn't finish writing yet. Oh, 49. Because I already did 48. Thank you. Yes, yes, thank you, thank you. So 49. I was going to do 48 again. 8 minus 5i over 8 plus 2i. Okay. So let's multiply and divide by the conjugate of the denominator. 8 minus 2i. And so 8 times 8 is 64. 8 times negative 2i is the negative 16i. Negative 5i times 8 is the negative 40i. Negative times negative is positive. 5 times 2 is 10. I times I is I squared. The denominator is a product of the sum and difference terms, so it's equal to the difference of their squares. 8 times 8 is 64. Positive 2i times negative 2i is a negative 4i squared. And so this is equal to, again, I squared is negative 1, so this is just 64. Minus 16i minus 40i is minus 56i. And again, I squared is negative 1, so it's minus 10 over 64. Minus 4i squared, well, again, I squared is negative 1, so this becomes a plus 4. And so I get, oops, I get 64 minus 10, 54, minus 56i over 68. Okay. And so let me write this as 54 sure, let me do that. Okay, so let's do 8 plus 2i times 8 minus 2i. So let's multiply this out. So I get 64 minus 16i. Now let's multiply this. Now I'm going to get a plus 16i. And then 2i times negative 2i is negative 4i squared. And so the middle terms cancel. So you just get 64 minus 4i squared, which is what I got here. Which, of course, I squared is negative 1, so it's really 64 plus 4, which is the 68. Any questions about that? Okay. And so I have 54 over 68 minus 56 over 68i. Notice that you can reduce that. And so let me divide both numerator and denominator by 2. So I get a 26i 7 over 34. Next, let's simplify this. The 56 over 68. And so let's divide both numerator and denominator by 4. And so 56 divided by 4, 14. 68 divided by 4, 17. And that is your answer. That's your answer written in standard form. Let me do problem number 50. Yeah, still not enough room. Okay, so I have 50. 1 minus 6i over 2 plus I. So again, let's rationalize the denominator. So let me get rid of the I in the denominator. So let me multiply and divide by the conjugate of the denominator. 2 minus I. Okay, so this is equal to let's multiply this out. 1 times 2 is 2. 1 times negative I is a negative I. Negative 6i times 2 is negative 12i. Negative 6i times a negative I is a positive 6i squared. 2 times 2 is 4. I times negative I is a negative I squared. And so I squared is negative 1. Well, let's first combine like terms. Negative I minus 12i is a negative 13i. I squared is negative 1, so the plus 6i squared becomes a negative 6. And similarly, the negative I squared becomes a positive 1. Since I have a negative 1 times the negative, gives me a positive. And so this is equal to 2 minus 6 is a negative 4 minus 13i over 5. And so this is the same as negative 4/5 minus 13/5 I. Let me do problem number 51. Find the power of I. So I to the 24. And so this is 24 is a factor of 4. So this is I to the 4th to the 6th power. Well, I to the 4th, I squared times I squared, is just negative 1. Negative 1 to the 6th power is positive 1. And so a negative 1 to the 6th is just 1. Let me do problem number 52. I to the 25. Well, I to the 24 plus 1 is I to the 25. So I to the 24 times I can write 24 as, again, just like above, I to the 4th to the 6th. Well, I to the fourth is -1 to the sixth is just 1 I, and that's it. Let me do problem number 53, I to the 54. Okay. So let me write. Well, let's see. 52 is divisible by 4. And so let's write 54 as 52 plus 2. And so this is equal to, well, 54, I'm sorry. Yeah, 54 divided by 4 is 13. So that's I to the fourth, the 13th power, times I squared. And so I to the fourth is 1. To the power of 13 will just be 1. So this is just I squared, but I squared is -1. Okay, so let's do 54. I to the 35. Well, let's write this as I to the 32 plus 3. I to the 32, well, that's the same as I to the fourth. 32 divided by 3 is 8. And so I have here, oh, it's equal to -1. So I squared is -1. Therefore, I to the fourth, which is I squared times I squared, -1 times -1 is a +1. So I to the fourth power is 1. But I squared is -1. Well, any of the perfect square factors, so any of the multiples of 4 will just, I to a multiple of 4 will always be equal to 1. And so you're trying to sort of peel off those for 53. So you're trying to just peel off the factors of the multiples of 4. And so in this case, 52 is a multiple of 4. 52 is 4 times 13. And so that I to the fourth becomes 1. And so that's the basic idea, is you're trying to peel off multiples of 4. Okay? Okay, so this is equal to, just like above, I guess I'm going to have to erase this stuff here. I to the fourth to the eighth times I cubed. And so I just get a 1 times I cubed is I cubed. But I cubed is the same as I squared times I, and I squared is -1, so you get a negative I. 55. Three I to the fourth. Well, 3 to the fourth is 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. And so I to the fourth is, well, just 1. So your answer is 81. Okay, let me do problem number 56. Use the square root property to solve the equation. So 4x squared minus 60 is 0. Let me add 60 to both sides of my equation. So I get that 4x squared is 60. So I get 4x squared equals 60. Let me divide both sides of my equation by 4. So I get that x is equal to 15. And so that says that x is equal to plus or minus the square root of 15. Okay, let me do problem number 57. See if I got enough space there. I probably do. So let me do 57. So I have here 3x squared plus 45 is 0. Subtract 45 from both sides of your equation. So 3x squared equals negative 45. Divide both sides of your equation by 3. So x is equal to, and so x squared is equal to 45 divided by 3 is 15. And so I can take the square root, like use the square root property. So x is equal to plus or minus the square root of negative 15, which we write as radical 15i. Okay. So that's problem 57. Let me do problem number 58. And so, by the square root property, 2x minus 1 is equal to plus or minus the square root of 121. What's the square root of 121? And so, I get 11. Let me add 1 to both sides of my equation. So I get that 2x is equal to 1 plus or minus radical 11 divided by 2. So I get x is equal to 1 plus or minus 10 over 2. And that is your answer. Okay. Let me do problem number 59. Okay. So let's do problem 57. Let me insert a page. Okay. Good. So let me do problem 57. Oops. And so, wait, I did 57. Let me do 59. Okay, so I already did 56, 57, and 58. So let me do problem 59. X plus 4 quantity squared is 24. So it says that x plus 4 is equal to, well, plus or minus the square root of 24. Subtract 4 from both sides. And so x is equal to, whoa, wait. What's going on there? X is equal to a negative 4 plus or minus rad 24. I can actually write 24 as 4 times 6. Okay. And so this is equal to, screen went away. Okay, I'll get it back. Okay. There. Okay, so let me see if I can. Okay, now it should work. So see if it comes back now. It's back. Okay, good. Sorry about that. It's because the plug got unplugged for a second. Okay. So this is equal to negative 4 plus or minus. The square root of 4 is 2. So it's 2 rad 6. Okay. That's problem number 59. Let me do 60. I can't remember now. It's 59, so 60. 5x minus 1 squared is equal to 16 over 25. Okay. So let's use the square root property. So 5x minus 1 is equal to plus or minus the square root of, okay, so this is equal to plus or minus the square root of 16 over 25. But the square root of 16 is 4. The square root of 25 is 5. Okay. Let me add 1 to both sides of my equation. And so I get 5x is equal to 1 plus or minus 4 rad 5. Okay. Let's divide both sides of the equation by 5. Okay. And so x is equal to 1 plus or minus 4 rad 3 over 5. And that's your answer. Of course, you can write it nicer. I'm sorry. Did I say over 3? I meant over 5. Okay, so let me write this as, well, let's see. Um, oh, that's a positive 4. Okay. So let me multiply, divide by 5 to get rid of the fraction. So that's 5. 1 times 5 being 5. Plus or minus, the 5's cancel. 4. All over 25. And so, boy, that plus or minus looks like something else. Okay, so let's write each of our answers. So x is equal to 5 minus 4 over 25, 1 over 25. I don't know, the other root. And so this is 5 over 25. This is 5 plus the other one is 5 plus 4 over 25, which is 9 over 25. So we have two solutions to this quadratic. Okay. Let me do, I guess the last one then is 61. And so actually we've got room for 61. So first step is to subtract 47 from both sides of your equation. Hit x squared plus 16x is equal to negative 47. And so I want to complete the square. Since there's a 1 in front of since this is a monic polynomial, let me just take 16 divided by 2 is 8. And 8 squared is 64. So let me add 64 to both sides of my equation. 64 minus 47 is 17. And so, by the square root property, x plus 8 is equal to plus or minus rad 17. Subtract 8. So x is equal to a negative 8 plus or minus rad 17. And that is your answer. Okay, 62. Wait. So let me do problem 62. Oh, and you want to complete the square. And so I have 9x squared plus 18x plus 8 is 0. Okay, so I want to complete the square. So first thing to do is to subtract 8 from both sides of my equation. So my equation becomes 9x squared plus 18x equals negative 8. Okay, so now let's take 9 times 2 is 18. So 18 divided by 18 is 1. And 1 squared is 1 times 9 is 9. Let's add 9 to both sides of my equation. And so 9 minus 8 is 1. Okay. Divide both sides of your equation by 9. And so I get x plus 1 squared is 1/9. And so, by the square root property, x plus 1 is plus or minus the square root of 1/9. But the square root of 1/9, well, the square root of 9 is 3. So this is just equal to the square root of 9 not being 3. And that's your answer. Let me do, oh good, it's only 86. Let me do problem number 65. Question. How about the 1? Yeah, how about that? Subtract subtract 1 from both sides of my equation. And so I get x is equal to a negative 1 plus or minus 1/3. And so let's evaluate this. So a negative 1 plus 1/3 is a negative 2/3. A negative 1 minus 1/3 is minus 5/3. Any questions about that? Okay. Let me do 65. Okay. X squared plus 10x plus 3 equals 0. Okay. Oh. Let me do problem 63. Okay, so problem 63. Okay, so Right, because we did 62. No. No, wait, we did 64. No, wait, we didn't do 64. That's 62. What the heck? I put down 60. Then what the heck? What happened to 61? Okay. It was 62. Yeah, that was 62. But that was 60. I never did 61. Okay, so that was 62. Yeah, I never did 61. Oh, next to the problem on the sheet. Oh, I see. Okay, thank you. Thank you, thank you. Okay, you did. Okay, so 63 is the next problem then. Okay, sorry about that. Okay, so 8x squared minus 5x plus 1. So you want to solve this by completing the square. Subtract 1 from both sides of your equation so that only the x's are on the, say, left-hand side of the equation. And so 8x squared minus 5x is equal to negative 1. So let's rewrite this as a square. Oh, no matter what, it's going to be sort of horrible. Okay, so I have a constant in front of the x squared, so I'm going to have to use that. And so I have a negative 5 divided by 2 times 8, 16. So negative 5 over 16 squared. Well, that's going to be a 25. Oops. So 5 squared is 25. 16 squared is 256. Divided by 8 is 32. So you've got to add 25 over 32 to the side also. Okay. And so you get let me write negative 1 is 32 over 32. So negative 32 plus 25 is a negative 7. Negative 32 plus 27 is a negative 7 over 32. Okay. Let me divide both sides of my equation by 8. So this is just x minus 15 over 16. Well, dividing by 8, same as multiplying 32 times 8, 256. Where did I get the 15? Oh, I'm sorry. That's a 5 over That's 5. You, that's 5 over 16. That was a typo. Okay. And so, by the square root property, x minus 5 over 16 is equal to, well, if you take the square root of this, you're going to get an imaginary number. So you'll just get an I times the square root of 7 over the square root of 256. The square root of 256 is 16. It's a square root, not the square. So you take the square root of 256. That'll give you 16. Okay? Oh, how did I get 256? I multiply both sides of my equation by 1/8. So divide by 8, same as multiplying by 1/8. Okay. And so let's add 5 over 16 to both sides of your equation. And why is there no plus and minus there? Add 5 over 16 to both sides of the equation. So x is equal to 5 plus or minus I rad 7 all over 6. Okay. Let me do, that was 63, right? Let me do problem 64. X squared minus 4x plus 13 equals 0. And so, let me bring the 13 to the right-hand side of the equation. So let me subtract 13 from both sides of my equation. And so I get x squared minus 4x equals negative 13. Okay, so negative 4 divided by 2 is a negative 2. And negative 2 squared is 4. So let's add 4 to both sides of the equation. 4 minus 13 is negative 9. And so, oops, I need more room. So let's use the square root property. And so I have that x minus 2 is equal to plus or minus the square root of negative 9. And well, negative 9, the square root of negative 9 is just 3i. Let me add 2 to both sides of my equation. And so I get that x is equal to 2 plus or minus 3i. And that's your answer. Okay. Let me do problem number 65. And so, let's see problem 65. Use a quadratic formula to solve. Okay, so x squared plus 10x plus 3. So it's already written in the correct form, so I can just use the quadratic formula right off the bat. So I have the quadratic formula, x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to b is a positive 100, so negative b is negative 100. Okay, so x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to a negative 10 plus or minus the square root of 100 minus 4 times 1 is 4 times 3 is 12. Oops, 2 times 1 is 2. Okay, so let's evaluate this. And so x is equal to a negative 10 plus or minus the square root of 88. Let me write 88. Let me write 88 as 4 times 22. The square root of 4 is 2. Okay. So these are the two solutions to your equation. You could factor out a 2. And so the 2's cancel. Okay. So x is equal to a negative 5 plus or minus rad 25, 22. Okay. $66. Okay. 3x squared minus 4x minus 7 equals 0. Okay. So let's use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops. Okay. So b is negative 4, so negative b is positive 4. Plus or minus the square root of, well, b is negative 4 squared is 16. 4 times 3 times negative 7 is a negative 84. And so I get all over 2 times a. 2 times 3 is 6. So x is equal to 4 plus or minus 16 minus 84 is 18. 68. Okay. 16 minus 84. 68. Correct. Screen went away. Okay. 1 second. Let me get it back. Hmm. Okay. So let's see if that works. Okay. So it's back. Okay. Good. 16 minus 84 is a negative 68. And so let's say I can divide that by 4. So this is 4 plus or minus rad negative 4 times uh, yeah, 17 over 6. Let me add another page. Okay, so this is equal to 4 plus or minus the square root of negative 4 is 2i. We're at 17 over 6. I can factor out a 2 from every term. So if I cancel, I'll just get 3 on the bottom. So it'll be 2 plus or minus I rad 17 over 3. Okay. Okay, so 67. Actually, maybe that's what I'm going to do. Because we're supposed to be done at, oh, in 10 minutes. So there's no way I can finish this off. I still have like 20 problems to do. Okay, so let me do that. Let me just in these first few problems, I guess. Let's end it at this time, and then I'll do another session. Yeah, I'm actually somewhat overly tired because I had a headache, so I took a whole bunch and allergies, so I took a whole bunch of Benadryl. So I am actually falling asleep during this. So let's do this. I guess tomorrow night I'll finish off the rest of these. Okay, so I guess that's it for today. Yeah, me too. Okay, so let me finish that off. Okay, so see you guys.